And then problem 3. Okay, so we're just trying to see the combined force being put on these two dogs. What is the resultant vector? That's what's being asked here. What is the resultant vector of these 3 dogs pulling? Now, when I set up my picture, I know that dog 1 has a magnitude of 8 newtons. Dog 2 has a magnitude of, I'm sorry, I did that wrong. Dog 1 has 10 newtons. Dog 2 has 8 newtons. And dog 3 has 13 newtons. I also know that the degree between 1 and 2 is 100. Between dog 2 and dog 3 is 150. And that's it. That's all we're given. In order to calculate this, we have to define our standard position. Now, I saw a lot of people while I walked around the room put X and Y coordinate just like normal, straight up and straight down. I'm going to take a little bit more liberty than that, and I'm actually going to make my x-axis line up with dog 1. So I'm going to shift my coordinate. I'm going to rotate it so this is the x-axis. This dotted line I'm drawing right through here is the x-axis. Now dog 1 is at standard position. Its degree here is 0 degrees. From standard position, dog 1 has a direction of 0 degrees. Now I'm going to put in my y-coordinate, my y-axis, make it as close as I can to 90 degrees. This isn't drawn perfectly. No, that's not drawn perfectly at all. Let me try that again. Okay, so this is my y-axis, drawn to the best of my ability. Now I can set up this problem. If dog 1 is 0 degrees from standard position, what's dog 2 from standard position? If this is standard position, how much do I rotate to get to dog 2?
100 degrees.
Very good, 100 degrees. Okay. Again, if this is standard position, how much do I rotate to get to dog 3? 250 degrees. So what I've written here in blue is the magnitude of each vector. In green is the direction from standard position of each vector. Why is it that I found those 2 values? What am I going to do with those 2 values? Come on, guys. What's going on? Somebody knows what to do. I see it on a lot of people's papers. Somebody answer me. Yes?
Is that where you do like the cosine and sine?
Right, I have to use cosine and sine. What am I trying to find when I'm using cosine and sine?
X and Y.
X and Y. I'm trying to find my components of the vectors. I need to find the horizontal component and the vertical component of each vector. Of dog 1, of dog 2, and of dog 3. And we have formulas for these 2 components. What is the formula for finding the x value, the horizontal component of your vector? Well, I use cosine, but that's not the formula.
Like, it's the magnitude cosine, the direction, I mean the angle.
Very good. Magnitude times the cosine of the angle from standard position. If you use it from standard position, it's going to make your calculations a lot easier. So then what is y? The formula to find the y component. Yes.
Magnitude, sine.
Thank you. This is when we use sine. We're going to use these formulas to find the components of dog 1, dog 2, and dog 3. So dog 1 is going to be x equals 10 times the cosine of 0 degrees. Y equals 10 times the cosine times the sine of 0 degrees. I'm using the formulas, and I'm substituting these values into my formulas. The magnitude of the vector is 10. The direction from standard position is 0. Because we have the unit circle memorized, we know the cosine of 0 is 1, and the sine of 0 is 0. So this is 10, 0. All of my forces in the x direction, there is no y direction. Then we can take our next one, dog 2. Same formulas, different values. X equals 8 times the cosine of 100 degrees. Y equals 8 times the sine of 100 degrees. And our components are going to be negative 1.389 and 7.878. And then we can take vector 3, dog 3, same formulas. X equals 13 times the cosine of 250 degrees. Y equals 13 times the sine of 250 degrees, giving us the components negative 4.446, negative 12.216. A lot of you haven't been using your angles from standard position. You've just been using a reference angle. That's okay. However, when we use it from standard position, it takes into account, your calculator knows, oh, that means I'm in the second quadrant. Oh, or that means I'm in the third quadrant. And so you don't have to think about your negatives. On your last test, a lot of you missed these problems because you didn't account for a negative. You didn't account for what quadrant the vector is in. Dog 2 is in quadrant 2. Any vector in quadrant 2 has an x value that's negative. Dog 3 is in quadrant 3, although it doesn't really look like it. It is in quadrant 3. It's 250 degrees. That's quadrant 3, which means the x and the y value are negative. Don't lose points because of negatives. Now what do I do? Okay, so I have the components of these 3 vectors. What do I do with them? Add them up. Find our resultant. Let's add these up. Your resultant is the sum of these 3 vectors. So our resultant is going to be 4.165 and negative 4.338. There's our resultant. Remember, this is our x component, this is our y component. I can take these values, substitute them into the formula for magnitude, and the magnitude of our vector is going to be the square root of 4.165 squared plus, notice my use of parentheses around my negative number. Your calculator does not know how to properly square a negative unless you put them in parentheses, equals about 6.014 newtons. That is the total amount of force being placed on this dog chew toy. Okay, what we're moving on to, we have to work on encoding and decoding messages like we did in our homework. We're going to get a